Hello and welcome to Bedroom Physics. This is the example video for multidimensional motion, uniform circular motion or just circular motion, and also relative velocities. Let's get started. This right here is a uniform circular motion problem. So what's happening is we have our buddy and they're hang gliding and they have a constant velocity upwards. So they're being propelled upwards, but they're also moving in a circle. So it has a perpendicular acceleration and also a velocity that's propelling them around the circle, but also a constant velocity that's propelling them upwards. So it's kind of like this. What we know is that the constant velocity upwards is 5 meters per second squared. The period is 4 seconds and the radius of the circle is 7 meters. So we want to solve for the velocity vector, which is a combination of the velocity radial and the velocity upwards. And that's going to allow us to solve for the radial acceleration, because the acceleration is not only causing a velocity that's moving our buddy around the circle, but it's also causing them to propel upwards in a constant velocity. So we're going to use this vector, or the magnitude of this vector, in order to solve for the radial acceleration. So if you recall from the concept video, we know that the velocity radial, or the velocity that's propelling them around the circle, is equal to 2 pi radius over the period. So that's going to be 2 pi 7 meters over 4 seconds, which is approximately 11 meters per second. And then we're going to use Pythagoras Theorem in order to solve for the magnitude of the velocity vector. And also, by the way, we also want to solve for the angle between the velocity vector and the horizontal, or the velocity vector and the velocity radial, because the velocity radial is on the same plane as the horizontal. So we're going to see that the magnitude of V is equal to 11 meters per second squared plus 5 meters per second squared, which is going to be equal to approximately 12.1 meters per second. And then we can solve for theta using arctan. So the arctan, and then of course it's going to be y over x. So it's going to be, well, in this case it's going to be the rise over the run, and the rise is the velocity in the z direction, or velocity upwards. So 5 meters per second over 11 meters per second, which is going to be equal to approximately 24.4 degrees above the x-axis, or above the horizontal. And then we can solve for acceleration radial, and it's going to be equal to 12.1 meters per second squared over the radius, if you remember from the formula, from the concept, which is going to be equal to approximately 20.9 meters per second squared. Okay, the next problem is going to be a relative velocity problem. Okay, so we're playing soccer for a friend. Our friend is running 7 meters per second north in respect to the ground, and I kick the ball to my friend and I give it a velocity of 11 meters per second at 43 degrees north of east. So we want to solve for the velocity of the ball in the frame of reference of our friend. So we'll have to do velocity of the ball in respect to our friend, and it's equal to the velocity of the ball in respect to the ground, plus the velocity of the ground in respect to our friend. Of course, we cannot add these two vectors because they're going in different directions. So we're going to have to do the y component and then the x component, and then use Pythagoras Theorem to put it all together. Okay, so let's do it in the y-axis, or in this case, north and south. So the y component, first let me put this. So the y component of the ball in respect to the ground is going to be the magnitude times sine theta, where theta is this degree here. And of course, since it's going north of east, it has a component going north and a component going east. And we're going to say north is positive in this situation. So our number here, this first term is going to be positive. And just to clarify, this is v ground in the y. And then we want to add the velocity of the ground in the frame of reference of our friend. Now, we have the velocity of our friend in the frame of reference of the ground. And our friend is moving away from the ground, or from a point on the ground, at 7 meters per second. So if we were to take the velocity of the ground in respect to our friend and set it so our friend is not moving, then the ground is moving away from our friend at 7 meters per second. So it's actually going to be the same magnitude, but the exact opposite direction. It's going to be going south. But if north is the positive direction, then south would be the negative direction. So we're going to subtract, or not subtract, but rather it's going to be negative. We're going to add a negative 7 meters per second. And this is going to be the velocity of the ground in respect to our friend and the y. And it's going to be equal to approximately 0.502 meters per second north. That's pretty small. I mean, these numbers are completely random, so like, I don't even know what they're going to be. I didn't realize it was going to be that small, but it's not a big deal really. Now we need to solve it in the x. So v ball friend in the x. Of course, the ground does not have a velocity in the x direction or in the east or west direction. So we're just going to disregard this velocity completely. And what we're going to have left is 11 meters per second times cosine of 43 degrees, because that is how you calculate the x component of a vector when you have the magnitude. And it's going to be equal to approximately 8.04 meters per second east. And now to find the magnitude of this, we're going to use Pythagoras Theorem. And it's going to be v of the ball in respect to our friend is going to be equal to 0.502 meters per second squared plus 8.04 meters per second squared. And it's going to be equal to approximately 8.06 meters per second. But vectors is not only a magnitude but also a direction. So our direction, or our angle, is going to be rise over run. So 0.502 meters per second, or I'm sorry, the arctan of the rise over run, and 8.04, and it's going to be equal to approximately 3.57 degrees from the x-axis. So our velocity vector of the ball in the frame of reference of our friend is going to be 8.06 meters per second, 3.57 degrees north of east. Okay, I'm going to split these examples up into two videos. The first video, or this video, I'm going to talk about uniform motion and relative velocities, and then the next video I'm going to talk about multidimensional motion.